Have you ever found yourself looking out at the ocean and just wondering why it's salty? It's one of those questions that seems so simple on the surface, but the answer, well, it uncovers this incredible planet-wide balancing act that's been playing out for billions of years. Here's the real puzzle. We know that rivers are constantly washing salts and minerals into the ocean, day in and day out. So logically, you'd expect the oceans to just keep getting saltier and saltier over time, right? So why aren't they just giant, lifeless salt lakes by now? That's the big question we're going to dive into. Because what's so amazing is that the ocean's saltiness has stayed pretty much the same for an incredibly long time. We're talking billions of years. It's like a perfect recipe that hasn't changed. And that kind of stability tells us there must be some kind of hidden system at work, something that's keeping the entire ocean in a state of perfect balance. Okay, so to really get our heads around this balancing act, we first need to understand what salty actually means in a chemical sense, because it's a little more complex than just the salt you have in your kitchen. On average, seawater is about 3.5% salt. So if you had a liter of ocean water, you'd find around 35 grams of dissolved salts inside. But what exactly are those salts made of? Well, it's not just one thing. Ocean salt is actually this complex cocktail of different dissolved particles, or what scientists call ions. And yeah, sodium and chloride, what makes up table salt, are definitely the main ingredients. But there are also significant amounts of sulfate, magnesium, calcium, and potassium in the mix. Now, here's where it gets really fascinating. The recipe, the ratio of all these different ions, is practically identical no matter where you go on Earth. From the chilly Arctic to the warm Pacific, it's the same chemical signature. And that's a huge clue that all the world's oceans are part of one vast, well-mixed, and actively regulated global system. So, where does all this salt actually come from? If we trace it back, it turns out there are two main sources feeding the ocean's saltiness. The journey for most of it begins on land. Rainwater is naturally a little bit acidic, and over millions and millions of years, that rainwater lands on rocks and slowly, chemically, breaks them down. This process releases all the minerals locked inside. From there, streams and rivers carry these dissolved minerals all the way to their final destination, the ocean. But that's not the whole story. The ocean also gets a big supply of minerals from its own floor. You see, deep down, seawater seeps into cracks in the Earth's crust. It gets heated up by magma and then shoots back out through what are called hydrothermal vents. They're like underwater geysers. This water is packed with even more dissolved minerals, adding to that chemical mix. Okay, so we've got salt constantly flowing in from rivers on land and from vents on the seafloor. At the same time, pure water is always evaporating from the surface to form clouds, leaving the salt behind. It's like a pot of soup on the stove that's always simmering. You'd expect it to get saltier and saltier, but it doesn't. So what's the secret? How does the ocean stay in balance? And that brings us to the other half of the story, the part that's often missed, the Great Salt Escape. It turns out that while salt is always coming in, the ocean also has ways of getting rid of it, which is how the whole system stays in equilibrium. The key to the whole mystery is this very simple but powerful idea. Salt doesn't just go in, it also comes out. For every bit of salt that's added, another bit is eventually removed. It's this continuous cycle of addition and subtraction. So how exactly does this salt make its exit? Well, there are three main ways. First, in some shallow coastal areas, seawater evaporates, leaving behind huge deposits of salt that eventually get buried and become rock. Second, countless marine organisms, from tiny plankton to big coral reefs, pull minerals like calcium out of the water to build their shells and skeletons. When they die, they sink, locking those minerals away in the seafloor. And finally, the ocean floor itself acts like a chemical filter, as certain minerals react with volcanic rock and get pulled right out of the water. So you can think of it as a perfectly balanced planetary salt budget. On one side, you've got the salt in column, the deposits coming from rocks on land and the ocean floor. And on the other, you've got the salt out column, the withdrawals, as salt gets locked into rock, used by marine life, and pulled out by chemical reactions. Over long stretches of time, these two columns balance out almost perfectly. Now, this whole balancing act, it's much more than just a neat scientific fact. This salt balance is actually fundamental to why life on Earth can exist the way it does. You see, salinity is one of the key things that drives our planet. Salty water is denser than fresh water, and this difference in density, along with temperature, creates the massive ocean currents that circle the globe. These currents are like a giant conveyor belt, moving heat around and shaping our weather and climate. This balance also creates the stable chemical environment that allows the incredible diversity of marine life to thrive. Without it, our world would be a vastly different place. So the next time you're near the coast and you can taste the salt in the air, just remember what you're really experiencing. It's the result of a quiet, powerful, and ancient balancing act. The ocean isn't just a big storage tank for salt. It's a living, dynamic system that's constantly managing it. And that balance is one of the core reasons our planet has remained so welcoming to life for so long.